are Group 2 from Dynamic Section 4. My name is Jenna Kojinza and my metric number is AA240942.
My name is Yong Weng Seong. My matrix number is AA240886.
Hi, my name is Tan Yisian and my matrix number is AA240441.
My name is Sham Sundar and my matrix number is AA240141.
We are going to talk about our mini project titled Studying the Motion of a Bouncing Ball, a Dynamic Kinematics Experiment.
Okay, here is our objective for this experiment. First one is to investigate the motion between the different type of ball during the free fall and rebounds by using the principle of kinematic. Next is to measure and compare the initial drop height H1 and the first rebound height H2 for each type of ball. Next is to calculate the potential energy loss for each ball based on the differences in drops and rebounds height. Next is to determine the coefficient of restitution as an indicator of the elasticity or bounciness for each ball. And last is to analyze the effect of material and the mass on energy dissipation and rebounds efficiency during the collision with the ground.
Hello everyone, so now I'll be introducing on this experiment now. So as you already probably know, that when the ball is dropped, it is not returned to its original height. This is due to a few factors. And so when a ball is dropped and when it collides, some of the energy is lost into sound and heat, thus making that the potential energy for the initial height is not the same as the potential energy for the final height. Thank you.
Okay, here is the apparatus that we use in this experiment. First, we have 3 different types of balls. The function is to observe and to compare the difference between the energy conservation and energy loss between the 3 different types of material balls. Next, we have a measuring tab. The function is to measure the drop and the rebound height for energy calculation. Next, we have a ruler that we use to measure the small distance or diameter accurately. And last, we have a phone camera that we use to record all the experiments that we conduct. Now, I'm going to talk about the procedure of the experiment. Firstly, we gather all the required apparatus, which include football, basketball, and steel ball, a ruler, a measuring tape. Next, we set up the measuring tape vertically with the bottom aligned at a 0.1 meter reading. This 0.1 meter mark is considered as our ground reference point. Next, we drop each ball from a height of 0.7 meter above the ground, which corresponds to the 0.8 meter mark on the measuring tape. We will start with the basketball. It was dropped from a 0.8 meter mark and allowed to bounce freely. We perform 3 sets for each ball to ensure a more accurate and reliable result. After completing the basketball trials, we repeated with the same steps for the football and the steel ball.
Hello everyone, so I'll be explaining the theory part for this experiment. And the formula that we'll be using for this experiment is the potential energy, which is calculated in joule. So the formula is mass multiplied with gravity and height. And all the units for this formula is all in SI unit. So for mass, we'll be using gram, and gravity is 9.81, and for the height will be meter. And for this formula, there are 2 heights, the initial height and the final height. Thus, from getting both these heights, we'll be able to find the change in potential energy, which is mass multiplied with gravity and initial height minus the final height. Secondly, since for this experiment we are bouncing the ball, so that we'll be using the coefficient of restitution. And this formula is to measure how elastic and bouncy the collision is. So there will be 2 formulas. square root of that. So there are three scenarios for this experiment. One would be perfectly elastic collision. Second would be perfectly inelastic collision. And the third one that we will be using is the real world collision, where some of the energy is lost into heat or sound. Thank you.
So I'm now going to talk about the result of our experiment. In this experiment, we're doing three types of balls. First, with basketball, football, and steel ball. And for each ball, we're doing three sets of trials to get the average height. So for basketball, the initial drop height are set, which is 0.7 meter. And the rebound height for the first trial is 0.42 meter. For the second trial is 0.43. For third is 0.42. So we get the average height is 0.42 meter. For football, still the same, the initial drop height is 0.7 meter. And for the first trial, we get 0.35 meter. For second, we get 0.38 meter. And for the last one, we get 0.36 meter. So the average rebound height, we get 0.36 meter. For the steel ball, the initial drop height is still the same, which is 0.7 meter. And for the first trial, we get 0.59 rebound height. And for the second, we get 0.59 also. And for the last one, we get 0.57 rebound height. So we get the average rebound height is 0.58 meter. Data analysis. By using the initial drop height (h1) and the first rebound height (h2), the relationship change in PE equal to mg h1 minus h2 and CR equal to square root h2 over h1 can be applied to analyze the energy change during the bounce. The equation change in PE equal to mg h1 minus h2 represents the potential energy loss by each ball after the first bounce, while the coefficient of restitution CR calculated using square root of h2 over h1 shows how much energy is conserved in the form of outward motion. By comparing the values for the basketball, football, and steel ball, we can evaluate how mass and material affect energy loss and rebound behavior. These formulas allow us to quantify and compare the energy efficiency of each ball before performing the detailed calculation in the next section.
From the information, we can use to find coefficient of restitution. So, the coefficient of restitution is basically the percentage of potential energy remain after bounce. And the formula for it is square root of h1 over h0, where h1 is height after bounce and h0 is initial height. So to find the coefficient of restitution of basketball, we can just sub the value into the formula, where is square root 0.42 over 0.7, and we just use calculator and we found that it is 0.7745. This means the potential energy remain at the bounce is 77.45%. We do exactly the same step for football and steel ball. After we calculate, we found that steel ball have 86.19%, which is the highest, and the football is 71.7%, which is the lower. As a conclusion, we found that football has the lower potential energy loss compared to basketball, although basketball can bounce higher after bounce, because football is lighter than basketball. Basketball can bounce higher than football because basketball commonly utilize rubber and composite leather, while football are typically made with various synthetic material. Because basketball are designed to be very bouncy for dribbling, while football are designed for kicking and passing, where a high bounce isn't always desirable. The coefficient of restitution directly quantifies the elasticity of a collision by relating relative velocity, while the calculation of potential energy involves mass and gravitational field. Therefore, a direct inverse proportional between potential energy loss and the coefficient of restitution isn't a straightforward conclusion, as they are defined and calculated using different physical parameters.